Hello guys, welcome back to my YouTube channel. My name is Aditya and studying in Shri Venkateswara College of Engineering. My USN is 1V23CA005, studying in CSE Artificial Intelligence Department. Today I'm gonna explain about the topic called as concept of K-mapping and advantages and disadvantages of K-mapping in the subject digital design and computer organization, subject code BCS302. So let's start with the topic. First we have introduction to K-maps. So what's introduction to K-maps? K-maps or Karnaugh maps are a visual method used for simplifying Boolean expression. So these maps are the visual methods for simplifying Boolean expression. So basically Boolean expression is written on a paper or something which you imagine, but this is something which you can visualize over here. So it's why it's called a K-map. They provide a systemic way to minimize the number of terms in a logical expression. So systematically you can minimize the number of terms in a logical expression. So K-maps are particularly useful in digital circuit designs and optimizations. So K-maps are mainly used in digital circuits, as it's the subject of digital design. So it's used in digital circuits. This is a smaller version of the digital circuit, but the circuit will be very huge. And let's start with the smaller things only, right? Smaller things make us bigger in the future. So we have structure of K-map. A K-map is a two-dimensional grid representing all possible values of Boolean variables. Each cell in the K-map corresponds to a min-term of the Boolean function. The arrangement of cells follow a gray code sequence to ensure only one variable changes between adjacent cells. So each and every cell follows in sequential order so that only one variable is different from the neighboring cell or the neighboring block. So it's and the number won't repeat once again. So if 0 is there, 0 will only be there. If 10 is there, only 10 will be there only once. So the numbers won't repeat once again. So we have how to use K-map. So to use a K-map, start by plotting the minterms of Boolean function in the appropriate cell. So first we have to plot the minterms in the appropriate cell. Identify groups of ls in the K-map that can be combined to form simplified expression. So we need to group the number of things. For example, we have one grouped over here like this and one another like this, and one band, one another one is separate over here. So we need to identify and group it. The goal is to cover all the ls with the fewest number of goals, resulting in a minimized expression. So the goal is to cover all of the number with the fewest number of groups, resulting in a smaller or very less expression like we have in the photo over here. Next we have grouping rules. So as there is rules for each and everything, even if you have to go and play a small game also, you will have a rules for each and everything. Like that only we have rules for even grouping K-map also. So grouping can be formed in sizes of 1, 2, 4 or 8. So basically it's in the power of 2, so to the power of 0, to the power of 1, 2, to the power of 3, or larger powers of 2. It's written over here. Each group must be rectangular and can be wrapped around the edges of the K-map. It is rectangular and wrapped around the edges of the K-map. You can include don't care conditions to form larger group and further simplify the expression. So you can use the don't care for creating larger group. So what is the advantages of K-map? K-map provide a visual approach that is easy to understand and apply. They can simplify complex Boolean expression without the need of lengthy algebraic manipulation. So we don't need lengthy algebraic manipulation for Boolean expression, and it can be simplified using K-map. K-maps are ideal for functions with 4 or fewer variables, making them practical for many digital circuits. Next we have disadvantages of K-map. As we have the advantages of K-map, we also will have a disadvantage of K-map. So what are the disadvantages? Let's see over here. So we have K-map becomes cumbersome and less practical for functions with 5 or more variables. So it's used for practical only for variables which is less than 5, and more than 5 it becomes a bit harder. The manual grouping process can lead to human error, and if not done carefully, So if it's not done carefully, it can lead to human error. K-maps do not easily accommodate functions with large number of variables or complex relationships. And next we have applications of K-map. So what are the uses or applications of K-map? We are going to see here. K-maps are widely used in design and simplification of digital circuits, as we discussed in the starting of the topic only. So it is mainly used in the simplification of digital circuits, which might be in bigger number, but the K-map is smaller over here. They are also applied in optimizing combinational logical designs and reducing gate count. K-map play a crucial role in teaching digital logic and circuit design principles. What are the limitations in educational context of K-map? While K-map are effective for learning, they can create misconceptions about simplification. Students may rely too heavily on visual methods and neglect algebraic skills over here. So that's one of the limitation, and reinforcement of both visual and algebraic techniques is necessary for well-rounded understanding of this K-map. So we have next one, which is alternative simplification techniques. So what are the alternative simplification techniques of K-map? We have other methods like Cuny-Maclaurin algorithm can be used for larger functions over here. It is essential to choose the right method based on specific requirements of the problem. Computer-aided design or CAD tools often employ more complex algorithms for optimization. So we have conclusion. Conclusion is K-map are a very valuable tool for simplifying Boolean expressions in digital design. Despite their limitations, they remain a fundamental concept in learning about logic circuits. Understanding K-map lays the groundwork for more advanced topics in digital system design. So that's all for the video, guys. Thank you for watching the video until the end. If you think my content was useful, please like the video, and if you want more content like this, make sure you subscribe to the channel. And thank you for watching until to the end. Thank you.